This will be the first of two videos on optics. The first one will be on drawings for mirrors. The second one is for drawings for lenses. There are a total of 4 lines you can draw. This video is going to focus only on 2 of them. The other 2 will be taught in class. They are a little bit more complicated. So we're just going to focus on these 2 main rays that work for every single type of mirror, regardless of whatever, if it's concave or convex, or the position of the object. The first ray goes through the focus, and then it goes parallel. The second ray goes parallel, and then it goes through the focus. There's 3 types of setups we can have. 2 of them are for concave. 1 of them is for convex. For concave, this first one we're going to focus on is our object is positioned outside the focal point. It could be very close, say here. It could be very far, say back here. The only thing that's going to change is how big the image will be. The image is always going to form down here for this type of situation. It will be inverted, and it will be on the same side of the mirror as the object. So our first ray goes through the focus, then it goes parallel. The second ray goes parallel, then through the focus. We see the 2 lines intersect right here, and therefore that's where our image will be. In this case, it's a little bit smaller than the object. It is inverted and is on the same side. For an object beyond the focal point, this is how all images are going to appear. If it's a concave mirror, it'll be on the left side of the mirror and inverted. The second type of concave is if the image appears or is positioned, if the object is positioned inside the focal point, but the method's still the same. We come from the focal point. Notice that the ray starts at the object, but if I were to trace it back, it would go through the focal point. So from the focal point, hits the mirror, then goes parallel. The next one, parallel, then through the focal point. Now we notice these 2 rays do not intersect, therefore we're going to trace them backwards. We're going to draw them dotted on the right side of the mirror because they're virtual. And we can see that these dotted lines intersect right here. That's where image appears. Now in this setup, with the object inside the focal point for all concave mirrors, we're going to see that the image will always be upright, it'll be bigger than the object, and it'll be virtual. Now before I go into convex mirrors, I really can't test you on this through Blackboard, so it's just going to be one question. You're going to have 2 minutes, and it's just going to say what is the code, and the answer is 314. So again, the answer is going to be 314. You can remember that easily because that is the first 3 digits of pi. There's no period, just 314. You put that in there, you get 5 points. Last one, convex. Is going to follow the same pattern, but we have to be careful. Our line that's going to the focal point is going to hit the mirror before it can actually hit the focal point. We don't continue to trace it to the focal point. We turn around and send it back parallel. The second ray, parallel. And now it should go through the focal point, but it can't because it hits the mirror. So we're going to draw it as though it's come from the focal point. So you'd position your ruler to connect the focal point and this position here with the mirror, and you'll draw the line back. We see once again these 2 rays do not intersect each other, so we're going to trace them back dotted because they are virtual. And we see an intersection right here. Our image is going to be dotted because it too is virtual. With all convex mirrors, the image is always going to appear on the opposite side of the mirror as opposed to the object. It will be smaller, it will be upright, and it will be virtual. So the 2 rays to the focal point and then parallel, and the second ray is parallel and then to the focus or if it's convex, appear to have come from the focal point. Thank you for watching.